Alright guys, in this video we want to talk quickly about calculus, differential calculus. I'm sure you understand that we have different parts of calculus. We have the differential calculus and we have the integral calculus, integration. So under differential calculus we talk about differentiation, and under the other one we talk about integration. So right here we will also be discussing later about the application of both of them, but let's start from the basics. And presently now, under differential calculus, I would love to talk about a very important subject, and that's functions. So functions are a very essential part of calculus. Now, what are functions? What is the meaning of function? You need to understand that when you say something is a function of something, it's more like you saying something uh, is like a something depends on something. If I say you are a function of the blood in your body, you're a function of your blood. That means you are alive if your blood is available. If you lose a particular amount of blood, you don't live anymore. That means you are dependent on your blood. So you are a function of not just your blood alone. Obviously, you are also a function of oxygen. So you can see a human being is a function of both blood, oxygen, and probably some other things. Food, for instance, water. Now that means we are made up of several. We are a function of several variables. Or do I call them variables in this case? But we're a function of several things essentially. So let's come back to mathematics. When we say function, we're dealing with uh, variables here. So we have the x variable and the y variable. So when we write f into bracket x, that's all saying a function with variable x. That's the meaning of f into bracket x. When you see what you can see right here, you see y equals to f of x. That f into bracket x, it means we are saying the function has to do with a variable x. That means that function is made up of x. So that function will deal with x. For instance, let me talk about certain functions that deal with x. X square, that's x square, that's a function. X square, I can say x plus 1. I can say x cubed plus 3. I can say square root of x plus 1. In short, when we say f into bracket x, that means we're saying a function that is made up of a variable x in it. So now when we say y equals to f into bracket x, that's us saying y has to do with y represents y is synonymous with a function of x. So in this case, that means y is actually the output variable, the response variable. Yx will be the input variable. So it's like saying y depends on x. You can only get a value for y if you input a particular value for x. If you don't put in a value for x, you can't get y. So y is the dependent variable and x is the independent variable. So let's read from what we have right here. We say a quantity y is a function of some other functions, so of some other quantity x, if the value of y is determined by the value of x. This is written as y equals to f into bracket x, read as y is a function of x, where y is the dependent variable and x is the independent variable. The independent variable is called the argument of the function, and the dependent variable is called the value of the function. So understand the differences. X is the argument. That's what you fix in several. You can fix in x as 1, x as 2, and the value of the particular function. That means what will be your output, the value, what you say the function is about, is your dependent variable, which is your y. So let's say let's say y equals to x plus 1, for instance. Y equals to x plus 1. That's a simple function. That means you are saying y is a function of x plus 1. That means the function says bring in a x value and add 1 to it. That's the whole function is made up of input a x value, then add 1 to that x value. That's a simple function. Now, if you fix in x as 1, then that means the value of that function becomes 2, which is your y equals to 2. So we say y is the value is the value of the function. That's why we say y is the dependent variable. Yx is the argument. So that's what is going to determine what is going to be changing. Your x will be changing. And once your x change, the value will change. Once the argument change, if the argument changes to 2 in that simple equation of x plus 1, that means your value of that function will become 3. If the argument changes to 5, then your value of the function will change to 6. If your argument changes to 10, then the value becomes 11. So that's just an introduction to functions. Now, let's all now talk about a different part when we're dealing with functions, and that's domain, codomain, and range. Domain, codomain, and range. I'll use this diagram right here to explain the unique differences between domain, codomain, and range. A lot of people misunderstand this, but let me make it clear to you. This diagram you have here is a very clear indication of what the three of them really means. Domain is that independent variable. Domain is that x variable, the value that you use to put into a function. Now, I'm sure you know mapping and functions are together. So when you see this arrow, you see there's an x circle, a circle that has x on top, and then there's another circle that contains y on top. You see that arrow? That arrow indicates the function. So that arrow can signify different things. It's possible that that arrow may be x plus 1. It's possible that arrow is x squared. Then it's possible that arrow is square root of x plus 1. It could be anything entirely.